Good morning all. Good morning all. Guys, is my voice audible? Is my voice audible, Amma?
Yes, sir.
Yeah, okay. So let's discuss so today's topic will be the special cases on Lemmy's theorem. Okay, so these special cases will let you know how better you can use this formula to calculate the radial and circumferential stresses. Okay, so let's share the screen. So by that we'll start doing this. Yeah. So yesterday we have started Lemmy's equation. So this equation is usually used to determine the radial stress and circumferential stress. Okay, so where the nature of the radial stress is under compression. Why? Because your thick cylinders is subjected to internal as well as external pressure, and the circumferential stress is under tension. Circumferential stress is under tension. Okay, so basically we have derived two formulas. So one is sigma r, so which is b by r square minus a, and the circumferential stress is b by r square plus a. Okay, so these two are your Lemmy's equation. Okay, so which is used to determine the radial and circumferential stress or hoop stress. So in this, basically the constants are a and b, isn't it? So a and b are constants. Okay, a and b are constants, and by that these a and b's are going to be evaluated based on the internal and external radial pressures. Okay, so these are going to be calculated based on the internal and external pressures. Okay, so usually pressure will always act towards its radius, isn't it? So if you see the thick cylinder or thin cylinder, so this is your P1 and this is your P2. So both are acting radially. Okay, so by that these pressures are called radial pressures under. Okay, so with respect to the radius. So what are the special cases? So these are very, very important even for your competitive exams. Okay, so let's discuss the special cases. So in these special cases, so this A and B's are going to be evaluated based on the internal and external pressures, as I told you, right? So what is your external pressure? So external pressure is P2 and your internal pressure is P1, isn't it? Okay, so where R is the radius 1 and 2, okay? So where sigma R is P1, so which is acting internally, and sigma R is P2, which is acting externally, right? So radius, there will be two kind of radius, and pressures also will be two types of pressures, right? So by that I can consider P1 as B by R1 square, B by R1 square minus A. Right, Shah? Why? Because if you see the radial stress, sigma R is equal to B by R square minus A. This radial stress can be written as B by R1 square minus A, okay, with respect to pressure P1. And what will be your P2? B by R2 square minus A. Okay. So these two are pressures. One is internal pressure, other one is radial pressure. Okay. So other one is external pressure with respect to internal radius and with respect to external radius. Understand? Okay. So these are all special cases, Sama, very, very important. So by considering radial pressures internally and externally, this radial stress is going to be evaluated in two forms. One is internal pressure with respect to internal radius, external pressure with respect to external radius. Okay. So by that, what are these two constants? Yesterday we discussed. What is this B? B can be evaluated with respect to radius and pressures. R1 square, R2 square by R2 square minus R1 square of P1 minus P2 and P1 R1 square minus P2 R2 square by R2 square minus R1 square. So these are the constants which are going to be evaluated based on the radius and pressures. Okay. So based on the internal radius and external radius, based on the internal pressure and external pressures. Okay. So by substituting these two values in this formula, you can able to evaluate the pressure P1 and pressure P2. Understand? See why this case is very important, you know. In your examination, they may ask you to calculate what is the internal and radial, sorry, what is the internal and external pressures in a thick cylinder. Okay. So internal and external pressures calculate like P1 and P2. You can make use radial stress formula to calculate the internal and radial pressures. Understand? With the help of this equation, B by R square minus A equation dwara, we can able to calculate. How better we can write this formula with respect to R1, you can able to calculate the internal pressure. With respect to R2, you can able to calculate the external pressure. Understand? So this is the case. So you can make use these two formulas. You can substitute them. Please substitute this A value and B value in these formulas. By that you can able to achieve the pressure P1 and pressure P2. Okay. So these two you can able to calculate. Understand? So this is one case where you can able to evaluate easily. So let me tell you. So this is the case one anamata. Okay. So through this you can able to evaluate. So let us say if you want to calculate circumferential stress and radial stress, also you can substitute A, B values in this. By that also you can able to calculate the radial stress and circumferential stress. Okay, with that also you can able to calculate. Understand? This is the case one. Very important. Please try to remember this. ఎప్పుడైతే సిలిండర్ లో రెండు ప్రెషర్స్ ఉంటాయో, ఓకే, అంటే ఇంటర్నల్ ప్రెషర్ ఎక్స్టర్నల్ ప్రెషర్స్ రెండు ఉంటాయో, ఇఫ్ యూ వాంట్ టు క్యాలిక్యులేట్ దోస్ టూ, యూ కెన్ మేక్ యూజ్ దిస్ కేస్ వన్ టు క్యాలిక్యులేట్ P1 and P2 with respect to the constants A and B. Understand? Right. So now let's discuss case 2. So by that you can able to understand in detail how these formulas are achieved and you know how they are going to be evaluated to calculate few more parameters. So end of the day we can write all the formulas in a single page also. By that it will be easy for you to remember and even to solve the problems. Okay. Yeah. So let me erase this also. Yeah. So what is the case one, Amma? Case one is the one where the cylinder is subjected to internal and external pressure. Okay. Understand? Yeah. So now let's see the case 2. Case 2 endante, your cylinder is subjected to internal pressure as P1 and there is no external pressure. And your external pressure is 0. What do you mean that? Your R is equal to R1 R is equal to R2. Avuna? But sigma R is equal to P1, sigma R is equal to P2, which is 0. And your cylinder is not having any kind of external pressure. Okay. So what are the formulas? P1 is equal to B by R1 square minus A. P2 is equal to B by R2 square minus A. Okay. So from this, you can able to write, you know,
P2 plus A వస్తుంది సార్.
sorry,
P2 plus A.
P2 is 0, isn't it? P2 directly it will be 0. Why? Because the pressure is 0, isn't it? So you can able to achieve only the pressure P1. So where your constants will be A is equal to P1 of R1 square by R2 square minus R1 square. And what is your B constant? P1 of R1 square R2 square by R2 square minus R1 square. Okay. So with these two, you can able to calculate your radial stress as P1 R1 square by R2 square minus R1 square, R2 square by R1 square minus 1. So this is your radial stress, and your circumferential stress will be P1 R1 square by R2 square minus R1 square of R2 square by R square plus 1. Okay. So by considering your external pressure as 0, so your complete P2 will become 0 with only with the help of the internal pressure. Okay. So by taking these two constants A and B, you can able to calculate your radial stress and circumferential stress without having any external pressure alone. Understand? So that's how you can able to calculate your radial stress and circumferential stresses with respect to only an internal pressure. Only an internal pressure. Understand? So here it should be very careful where you can able to understand the concepts. So here, what is your radius from center? This is your R1. From here, this is your R2. Okay. So chala mali confusion untundi. What is R1 and what is R2? R1 is the internal radius of the cylinder. R2 is the radius towards the external. Okay. So this is your pressure P1 and this is your pressure P2, which is acting from outer side and from the inner side. Understand? So the internal radius and external radius. So these are the nothing but R1 and R2. So mere anukochu, so pressure P2 0 aithe what happens to R2? R1 and R2 are constants. Okay, it always depends on the thick cylinder's dimension. Okay, so it's based on the thickness of the cylinder. The thickness of the cylinder may depend outundi. Okay, your R1 and R2, it will vary accordingly. Okay, based on the thickness of the cylinder. So this is the case where the internal pressure of the cylinder will have, but external pressure is 0. With respect to that, how can you evaluate your radial stress and circumferential stress anedi? We are understanding from this. Yeah, Chapanamma. See, someone is speaking. No? Okay. So this is the case 2. So where your cylinder is subjected to internal pressure and where your external pressure is 0. Okay. So now we will go with another case which tells that your cylinder is subjected to external pressure, but internal pressure is 0. Okay. So what happens to that case? Okay. Case 3. Case 3. Now, what is the case 3? So let us take your external pressure which is acting on the cylinder is P2 and the internal pressure is 0. So that means, so there is a cylinder, there is only an external pressure. Okay. So there is no internal pressure at all. సో there is only an external pressure and internal pressure ఏమీ లేదు. సో ఇలాంటి కండిషన్స్ లో what happens to your radial stress and what happens to your circumferential stress? Can anyone tell me, in this case, do you have any radial stress? అసలు ఈ సిగ్మా ఆర్ సిగ్మా సి లో ఏవి ఉంటాయి ఏవి ఉండవు చెప్పగలరు ఎవరన్నా?
రేడియల్ స్ట్రెస్ ఉండదు సార్.
Very good. Radial stress is zero and the circumferential stress will exist. Why? Because as there is no internal pressure, so when there is no internal pressure, there is no internal radial stress develops. But what happens to circumferential stress? The circumferential stress always acts within its circumference. Understand? So by that, definitely there will be a circumferential stress develops. So by that we are supposed to be calculated from this case. Okay, so by considering this, your R is equal to R1. Obviously there will be a radius. Your R is equal to R2. Sigma R, nothing but P1 is equal to 0. Sigma R is equal to P2, which is going to be exists. Okay, so what is your relations over there? So as you know, P1 is 0. P1 is equal to B by R1 square minus A. So as P1 is 0, so this is completely 0. Okay, and what is P2? P2 is equal to B by R2 square minus A. Okay, and P2 is exists. So from this, what is your constant B? B is equal to minus P2 R1 square R2 square by R2 square minus R1 square. Okay, and what happens to your constant A? A is equal to minus P2 R2 square by R2 square minus R1 square. Okay, these are the two constants A and B. So by substituting your A, B value, you can able to evaluate only one stress, that is your circumferential stress. And that maximum circumferential stress at radius R1 will be sigma C. By substituting A, B values in the above formula for evaluating your circumferential stress, minus P2 to R2 square by R2 square minus R1 square. Okay, so this is your circumferential stress only develops when your cylinder is subjected to external pressure alone. Okay, so that is how we have to know. Meeku formulas adukkopochu in competitive exams. If you remember these formulas, so by that they may just ask you to calculate what is the circumferential stress. Okay, from the conditions given. So what are the conditions? Ippudu varaku three conditions chusam. The first condition is when the cylinder is subjected to both internal and external pressure. Second condition is when the cylinder is subjected to only with an internal pressure. Third case is only an external pressure where internal pressure is 0. So by that, what things you can able to calculate anedi manam keen ga chudali. Okay, so by substituting these two constants in this formula, you can able to calculate the stress, which is a circumferential stress, as minus P2 of 2R2 square by R2 square minus R1 square. Okay, so this is your third case. And finally, fourth case. What is the fourth case, Amma? Solid circular shaft or a cylinder subjected to external pressure P2. What is that? So can you tell me what type of cylinder it is? Idu em cylinder, Amma? Hollow cylinder, isn't it? So why it is hollow cylinder? Why? Because it is having a defined thickness and internally there is some space. Okay, so by that it is a hollow cylinder antaru dinni. Ide kaakunda, let us take a solid circular shaft. And there is no internal radius, there will be only a solid circular shaft. What happens to that? What happens to the stresses anedi? Let's see once. Okay, so that is your fourth case anamata. Case 4. Solid circular shaft subjected to external pressure. Sir, what happens to internal pressure? What happens to internal pressure? Emoth internal pressure. As it is a solid member, will there any internal pressure? As it is a solid shaft, it doesn't have any internal pressure. There will be only external pressures develop. Avuna? Right. So which is P2. So when the solid circular shaft is subjected to only an external pressure, as undoubtedly, okay, there is no internal pressure at all. So by that, what we can able to calculate from this, your sigma R formula is P by R square minus A. Sigma C is P by R square plus A, which two are Lamy's equations. Okay, so since what is the statement? Sigma R and sigma C are not infinite at R is equal to 0. Avuna? Why? Why? Why your stresses are not depending on the radius here? Why? Because there is no internal radius at all. Okay, so internal radius and there is no radius at all. So there is only a solid shaft which is subjected to external pressure. Okay, so by that, by taking your radius as 0, why? Because there is no radius at all. So your sigma R will be minus A and sigma C will be just A. Okay, so like this you can able to calculate your circumferential stresses and radial stresses only based on the conditions given. Okay, so by that, if you remember all these conditions, it will be very easy for you to solve the problems also. In the problem immediately we have to calculate or we have to evaluate, I mean, what condition they have given, whether they given a cylinder which is subjected to both pressures, only one pressure internally or only one pressure externally, or whether it is a shaft or a cylinder. Okay, you have to go through all these conditions first, then only you can able to solve the problems easily. Okay, so let us do one problem. So by that it will be very easy even for you to understand the things. Okay, so the key conditions good petkunnamma, right? So these 4 cases are very, very important. Okay, so let's do one problem on Lamy's equation. Okay, yeah, so question ledhu ikkada, just I will read out the question and I will write down the given data. Okay, straight away, and later I will share you the notes, complete the thick cylinders notes share chestanu, where you can find even the problems also. Okay, today I will do it. Question entante, a thick cylinder pipe, there is a pipe, thick cylinder pipe, okay, of external diameter 300 mm, 300 mm, and internal diameter 200 mm. It's 200 mm. And what is the thickness of the cylinder? 100 mm, right? Is subjected to an internal pressure 20 Newton per mm square. Ante P1 ఎంత ఇచ్చారమ్మా? 20 Newton per mm square. And external pressure 5 Newton per mm square. Ante external pressure ఇచ్చారు. So as I told you, definitely your cylinders will have more internal pressure than the external pressure, amma. Okay, so determine the maximum hoop stress developed, ante circumferential stress enta develop ayindho calculate cheyamantunnaru, and draw the variation of hoop stress and radial stress across the thickness. Show at least 4 points for each case. Ante enti? So he is asking you to calculate what is the maximum circumferential stress okati. Along with that, he is asking you to draw the what is the variation of hoop stress and radial stress across the thickness. Across the thickness prakaramu మీ hoop stress circumferential stress ఎలా ఉంటుందో calculate చేయమంటున్నారు, isn't it? So ఎలా calculate చేస్తాం? అది ఇదే solid thick cylinders నేను ఇక్కడ కట్ చేస్తాను. Let's cut this section here. ఇది ఎలా కనిపిస్తుంది అంటే ఇట్ విల్ దీన్ని జూమ్ చేసి డ్రా చేస్తున్నాను. ఇట్ విల్ లుక్స్ లైక్ దిస్. Okay, isn't it? From center, what is this radius and what is this radius? ఎంతమ్మా చెప్పగలరా? ఎంత ఈ రేడియస్ ఎంత?
100 sir.
So the internal radius is 100, external radius is
150.
150. So which is R1 and this is R2. So R1, R2 is also known. R1 is equal to 100 mm, R2 is equal to 150 mm. Okay, right. So మిమ్మల్ని క్వశ్చన్ ఏమడిగారు? ఫస్ట్ థింగ్ he is asking you to calculate what is the maximum circumferential stress. Along with that, what is the variation of hoop stress and radial stress across the thickness? ఈ థిక్నెస్ లో ఎలా వేరీ అవుతుంది? నేను మీకు నిన్న ఒక పాయింట్ చెప్పాను. వాట్ ఈస్ దట్ పాయింట్? స్టార్ మార్క్ ఏంటి? ఇన్ ఎనీ థిక్ సిలిండర్ internal stresses will be maximum or minimum?
Maximum.
Very good. Internal stresses will be maximum, external stresses will be minimum. Avuna? Right. So by keeping that in mind, I can draw the stress diagram easily where the internal stress will be maximum and the external stress is minimum. So somehow your drawing will be something like this. నాకు వాల్యూస్ తెలీదు, బట్ నేను డ్రా అయితే డ్రా చేయగలుగుతాను. ఓకే, ఐ కెన్ ఏబుల్ టు డ్రా ఇట్. వాట్ ఆర్ ద స్ట్రెసెస్ యాక్టింగ్ హియర్ యాజ్ ఐ నో. ఇప్పుడు నేను చేయాల్సింది ఏంటి? ఐ హ్యావ్ టు క్యాలిక్యులేట్ వాట్ ఈస్ ద స్ట్రెస్ at this point and what is the stress at this point. What is the stress at this point and what is the stress at this point? In stresses, let us take this whole thing as radial stress diagram ga తీసుకుందాం. అంటే radial stress variation here, and let us take this stress diagram as hoop stress diagram ga తీసుకుందాం. Now my duty is to calculate what is the magnitude of the radial stress internally and externally. What is the hoop stress internally and externally. Understand? So this is what I need to calculate from this particular problem, right? So let's do this. So where you can able to calculate all the parameters, so with the help of the A.M.I.E equation formula, right? So what is that? So let's do this. First, I have to write all the parameters which I have given. Along with that, what is the diameter also? Let's draw this. Diameter D1 is equal to 200 mm. D2 is equal to 300 mm. Yeah. So what are the equations? Your circumferential stress is B by R square plus A, and radial stress is B by R square minus A. Okay. So these two are the A.M.I.E equations which we required to calculate the stress variation along with its thickness. Okay, right. So first let's see the boundary conditions. What are the boundary conditions in your chuta? Okay, so first boundary condition at R is equal to 100 mm. Okay, what is your pressure? Radial pressure entama? When R is equal to 100 mm, what is your radial pressure? R 100 అనేది ఎక్కడ? Internal, external? Internally. So when 100 mm is internal, what pressure I have to take? What pressure? P1 or P2?
P1 sir.
P1. How much P1? 20 Newton per mm square. Right? So by substituting these two values, 20 is equal to B by 100 square minus A. So let us keep this as one equation, sorry, third equation. So why? Because this will be your first two equations. Okay, A.M.I.E equations. And this is your third equation. Okay, and next boundary condition. What is your next boundary condition, Amma? at R is equal to 150 mm, your radial pressure is how much? 5 Newton per mm square. Why? Because this is the radial pressure which is this is the radius to the outer layer of the thick cylinder. By that your radial pressure is 5 Newton per mm square. Value enti? 5 is equal to B by 150. So let's keep here. B by 150 square minus A. So let's take this as your fourth equation. Okay. Fourth equation, right? So now by solving 3 and 4, so what parameter we can able to calculate? Can I calculate A and B's or not? With these two equations, can I get the values of A and B? Calculate checha by solving 3 and 4. Can anyone do it? By solving equation 3 and 4, can anyone tell me what is the value of A and what is the value of B? Chendama, use your calculators and tell me what is the constants A and B from these two equations. Let me write the two equations again here. Equation 3, equation 4. What is the equation 3? 20 is equal to B by 100 square minus A. 5 is equal to B by 150 square minus A. Equating these two. Okay. What is your value of A and what is the value of B? Or sorry, not equating, solving. Sorry. Solving these two equations. A value, B value entamma?
A 7, sir.
Very good. B?
B 27,400.
2,70,000. Correct?
Yes. Yes, sir.
2,70,000. Just mathematical equations ante. Okay. Even I think straight away you can do this in your calculators also, right?
Yes, sir.
Calculator load meeku direct option untundi. Yeah. So these two are constants. So this is how you can able to calculate your constants. So substitute your constants in your Lecture equations. Sigma C is equal to B by R square plus A. What is B? 2,70,000 by what is R? Known plus 7. So let us take this as your equation number 5. Okay. Right. So now let's do what is your equation number 6, which is a radial stress. Okay. So sigma R is equal to 2,70,000 by R square minus 7. This is your another equation. Let us take this equation as 6. Okay. So for straight away chondama. So first Lecture equations are there. After that we took the boundary conditions based on the cylinder. Okay, based on the R1, based on the R2. So these two boundary conditions dwara we have arrived at two equations, okay, to calculate your constants. Ee constants calculate cheyadaniki we took the boundary conditions. After calculating these boundary conditions, we are substituting all these constants values in the Lecture equations to determine the radial stress and circumferential stress by keeping your radius unknown. Okay. So chundri R anedi unknown ga teeskuni, let's two more equations we have derived. Now to draw variations of hoop stress and radial stresses, what we have to do? Substitute your R, okay, R value in this equation wherever you want to calculate your stresses. అర్థమవుతుందా? ఇక్కడ R అనేది unknown గా పెట్టుకున్నాను. So by that R is varying kada, R is constant kaadu kada. So in your cylinder R1 is known. What is stress here? What is stress here? What is stress at this point? What is stress at this point? Definitely at every point your stress will vary. Avuna? So by that, with these two A.M.I.E equations, you can able to calculate stresses, I mean circumferential stress and radial stresses wherever you require. Not only at 100 mm, not only at 150 mm, even you can able to calculate your radial stress at your required point. 125 mm దగ్గర అడిగారు అనుకోండి, substitute your R at 125 mm. By that you can calculate the circumferential stress. By that you can able to calculate the radial stress also. That is the reason why we have derived these two equations by taking R as a variant. Understand? So now let's take these equations to draw the varying stresses of hoop and radial. First take R is equal to 100. Okay, substitute your value in these two equations. 2,70,000 by 100 square plus 7. 2,70,000 by 100 square minus 7. What is your circumferential stress here? 34 megapascal. What is your radial stress here?
27
megapascal. మరి ఇక్కడ 20 megapascal మీకు దేంట్లో వచ్చిన వాల్యూ? What is your radial stress? Your circumferential stress is always under tension and your radial stress is always under compression, right? In the same way, let's take another boundary, another radial, as let's take at 120 mm. Okay, R 120 దగ్గర క్యాలిక్యులేట్ చేద్దాం. సిగ్మా సి ఎంత? 2,70,000 by 120 square plus 7. R is equal to 2,70,000 by 120 square minus 7. ఇక్కడ ఎంత ఉంటుంది స్ట్రెస్?
25.75.
25.75. Very good. What is this? 11.75. Okay.
11.75.
Yeah.
Sir.
As we know, this is under tension, this is under compression. In the same way, let's calculate at another point which is at 135 దగ్గర calculate చేయండి. At another point at 150 దగ్గర calculate చేయండి. So why I am calculating at different points? Why? Because you should know how the stress varying from 100 mm to 150 mm అనే తెలియాలి. Okay, అందువల్ల మనం calculate చేస్తున్నాం. If you calculate these two values, straight away answers రాస్తున్నాను. Your circumferential stress will be 21.81 megapascal and this is will be 7.81 megapascal. And at 150 mm, your circumferential stress will be 19 megapascal and your radial stress will be 5 megapascal. Okay, so this is under tension, this is under compression, this is under tension, and this is under compression. Okay, see, so with this, all these values, you can able to draw the stress diagram very easily. First question, what is your first question in the problem? Determine the maximum hoop stress developed another. In this, all these values, which is the maximum hoop stress? Which is the maximum hoop stress? There are few hoop stresses here. 34, 25, 21, 19. Maximum ekkadundi? 34 megapascal. Ekkadundi 34? At
100.
Radius of 100. What do you mean radius of 100? That means at
Internal
radius, internal surface lo maximum circumferential stress undi. Okay, so by knowing all these values, draw the cylinder section. Okay, and you can able to locate the stress diagrams easily here itself. Okay, so ila meeru locate chesi so what is this? 20, this is 5. So what are these values, Amma? These are your radial stress. What is these values? 35 or 34?
34, sir.
34